Hey guys, welcome back to another study session. In this one, we're going to be doing find the number of subarrays where boundary elements are maximum. And so in this one, you're given an array of positive integers nums, and you want to return the number of subarrays of nums where the first and last elements in the subarray are equal to the largest element in the subarray. Okay, so let's take a look at the example. So 1, 4, 3, 3, 2, and then this one. Okay, and then here there's 6. Here's 1. So 10 to the 5th, so we can't do like n squared or dp or something, probably. So typically when you want to combine like here, because we have a subarray, sliding window kind of makes sense, at least the initial thoughts. And when you want like the max or the min, like you typically want a monotonic stack or queue or something. So the idea is like, well, let's just write some notes down here, like what can happen, what we need. So basically, let's say we have an array like 4. So anytime we have a first element and a last element, right? Anytime there's an element that's bigger, we can no longer include any of this, right? So basically, if this is bigger than the 4, then like we have to start over. Which means we probably want a decreasing stack. Now, what if there's a tie? Actually, do we want a decreasing stack? So basically, like, if our element is bigger than other stuff, we want to be popping. We don't want to be saving. Yeah, I think we want a decreasing stack in that case. And yeah. Okay. So let's walk through what would happen with a decreasing stack. So maybe we'll save like the index of where we're at. Also, we want to be deleting indices. Like, actually, do we want to be deleting indices in this case? No, because it can be like as long as we want. Yeah, so we don't need to be deleting. Okay, so let's say with like 1. So we'll just put in, let's take this example and let's walk through like what we would do, some ideas here. Okay, so basically we'd say like, okay, so there's no stack, so we'll just add the 1, and we need to figure out like, okay, for these subarrays that end with 1, like how many are there? And is it the length of the stack? No. Yeah, it's definitely not the length of the stack. I think it's like how many yeah, well, let's figure it out. So right here we have 1, so like our result will be 1. And this will be an index or the number and the index, but let's say we just store the 1. So now we hit a 4. So we know for sure like this can't be in our subarray. Yeah, this can't. Maybe we don't need an index. Not sure. So we hit a 4. The 1 can't be in our subarray for sure, so we delete it. Then we put in the 4, and now we have 2. Okay, now we have a 3. And we don't want to delete the 4 because what if we run into a 4 like over here? So we want to save that 4, but we want to add the 3. And now I think what we want basically is to know like, so because this is decreasing, I think we can maintain a count. And I think that's going to solve our problem. Yeah, so instead of just storing the number, we'll store the number and the count. So basically we'll say like, okay, we have a 4 with a count of 1. And now we have a 3 with a count of 1. And then we can just look at like what's the end of the stack, and that's how many new things we add here. So the end of the stack is 3 with a count of 1, so we'll just have 1. Now we have a 3 again. So if it was bigger, we would be deleting, but it's the same. So now we just update the count. And then this gives us 2 subarrays, so we have 5. And now we have 2, so 2 smaller, so 2 with a count of 1. Yeah, I think this is just it, to be honest. And 2 will give us 1, so we have 6. Let's go through the rest of the examples following the same, or I guess there's only one more, but let's try to do the same thing here. So I guess here we kind of obviously be 3 with a count of 1, 3 with a count of 2, and 3 with a count of 3. So that's pretty straightforward. Yeah. Yeah, I feel like that's just it. So essentially we just store the number and the count. That way we don't have to go through it. We could also store like a map, but I think the count makes sense. And then that's basically the problem. So let's give that a go. So yeah, so let's do a stack, and we're going to have an int array here, and we're going to have like a stack. Honestly, don't use a stack very often. Just use an array list in Java, but it's fine. Okay, so basically now what we have to do is we don't care about the index at all, so you can just do a for each loop. Okay, so while the stack is not empty and the number is bigger, strictly bigger than strictly bigger than what's it called? Stack get last at index. So we have an index and count, so it would be index 0. Then we would do a pop. Yes. Okay. So if stack not is empty and num equals stack get last 0, then we just increase the count. So then we just increase the count here. Oops. Else, we need to add this new thing in here. Num1. All right. And then we do res plus equals stack get last next one. And let's see if we missed anything. Let's think about it first. Let's see if we missed, like, what edge case can break. So let's just, before running it, just like getting one, let's just think about like what can actually break this. So if we had like 1, 4, 3, 3, so this would be decreasing. Yeah. So basically, like these 3s will never be. If we hit another 4, like those 3s will never be used. Yeah, I think that's good. Maybe I missed something, but I feel like that's good. Let's see. Crap. Oh, this is just a long. So that's a pretty easy fix. All right. Yeah. Great. Yeah, this one I felt was a little bit simple. So I felt like I was missing something. But the takeaways from these kinds of problems are, so this is sort of like a sliding window. Well, not exactly, but basically like whenever you're concerned with like keeping track of the min or the max, a stack is good because then you can make it monotonic. There's something probably could be done with a heap as well, where you just store like numbers and then something like that. Well, let's see what the solutions are. So our solution is linear and you know, like people might be asking like, well, how do you come up with this? Like it's not intuitive. It's like, okay, well, we have a subarray, so we know we want something probably not DP because like a subarray is contiguous. So it's not going to be like take or not take. Like we can't have gaps. So in that case, we want like sliding window or 2-pointer or something like that. And because this min and the max, typically with the min and the max, you want to like what's good at doing min and max? A stack or a queue, because monotonic can like keep track of that. Something else might be like a binary search. It's typically good. Like what's the max number this can be or something? You can just binary search for that max. So that's another thing to look into. But in this case, like this worked out. So this is how I'd kind of recommend doing this, is like, you know, thinking like, what do I need? How do I get it? And let's walk through some examples. And then sometimes you miss an edge case here and there, and then you're like, oh, okay, the problem's wrong. But for the most part, you're going to be, you know, getting stuff correct. So the last part, let's take a look here. Solutions. Stack, monotonic. Yeah, so monotonic stack, hash table. Yeah, this is what I meant by that. So if we didn't have this count, we would basically need a hash table of how many times the element appears, but we don't need that. So let's see, if we're close to this, then we're doing good. Well, let's take a look, because Lee always has like the super efficient crap. Stack peak, stack is empty, stack push. Okay. Yes, this is basically that. like actually. So yeah, pretty happy with that in that case. And yeah, hopefully this was useful. Hopefully you got some intuition for these types of problems, and I'll see you in the next video. Thanks for watching.